All right, well, good. All right. Yeah, anatomy of an LLM. It's all about the data, stupid. It is the data. You're going to see, we'll see when we go through this, like, people will tell you, like, put your data in a vector database, and then we're going to talk about that, right? And they'll say, well, read a blog and it'll say, do it this way and it'll work perfectly. Then you'll read another one and they'll say, do it this way and it'll work perfectly. And what I found is, like, playing with this for like over a year now, is that the data determines the process. It's not the process. And that's really what the workshop was about, really showing everybody how you could take certain corpuses of data. And it'll apply very well to those last couple of questions too, about hallucinations. So one of the things, like, if we're going to do this, I might as well try to get you to buy my latest book, but it's about a guy named Dr. Deming. And so my hook is, like, if you want to go do some of these labs and stuff, I have a Hugging Face database with part 1 of my book. So you can actually use that and sort of learn how to take a corpus of data and turn it into something that you can vectorize, which, again, we'll go through all this. So who am I? I've been doing DevOps from day one. I'm not the Godfather. I'm the consigliere. Patrick DeVar is the Godfather. So, yeah, let's go on. Nobody laughed in my last session. This is awesome. I've done a lot of stuff. Somebody said I've written many books. I've done startups. Most of them are miserable failures, but I got kind of lucky. I sold a company to Docker. I sold a company to Dell, and those were 2 pretty good ones. So I was early in it. Chef. In fact, I was the first person to give a chef presentation at scale. So the first chef presentation at scale I gave. Yeah, that was pretty awesome. I got 2 newsletters. I've got this book called Profound. So if you're interested in that sort of vein, it's about management theory. And so I have a newsletter for that. But I'm actually writing a new book on the history of AI. So the way I've written a book is very much like how Michael Lewis would write a book. So think about how like a Moneyball version of the history of AI. So it'll be informative, but it'll be fun. And so I use my book. So primarily for this presentation, I've been playing with like 4 different corpuses of data and to vectorize, and I'll explain what that means in a little bit. But for this presentation, most of I've done is use my book. The thing I'll tell you is, these questions about hallucination and sort of bias and all that stuff is one of the ways to sort of counteract that is to create a vector database. And we'll go into that, right? And so vector databases are very important. It's not the only way. There are other ways, but the biggest bang for your buck these days is pick a vector database. And here's the key. Pick a data source that you know really well for your first sort of exercise. Something the data where, like, what the answers are supposed to be. And then there's sort of a stack. Remember when we had the LAMP stack? There's an evolving sort of Gen AI stack here. And so you use these stacks and you get to learn your data, what questions am I getting the right answers? And between metrics, between just looking at the answers, you have to remember the first slide said it's all about the data, right? You have to learn. This is not a simple task. A lot of people will say, well, John, I just took my PDF and I put it in Claude and look what it gave me. But if your LLM is going to be a handheld where people are climbing up on telephone poles and changing stuff, and the answer will kill them, right? Like, loading your PDF into Claude is not the answer, right? So that's the point. If it's a cafeteria, if it's your corporation headquarters, where's the best place to go to lunch? Load it into Claude, turn it into an LLM. But if it's high consequence and the answers are you can get sued, create toxicity, or people could die, then you're going to have to work on the data. And that's what this presentation is really about. So this is something we've been trying to play with. The sort of DevOps theme is, and I won't spend too much time on this, and I'd love to geek out. I'll be here the next couple of days. But we're trying to think about, like, what does the stack look like? And this is, I think, since we've worked on this, we've sort of thought of, like, the stack is simple. It's really orchestration, it's vector database, and it's observability, which is evaluations, right? I mean, it's more than that, but, like, that's a good way to think about, like, how we learned the internet was the LAMP stack, right? So think about, like, right now, you could sort of say to yourself, like, these are 3 that I could. If we're really going to get honest with ourselves, we're going to have to do a lot of LLM to LLM, mixture of agents or a mixture of experts. So, like, our answers, this is the ones where, like, if people are climbing up on telephone poles, we want to make sure that the answers are going through an end-to-end continuous process, and we're constantly monitoring the toxicity, the hallucinations, and I agree with somebody, hallucinations are just predictors of what the sort of vectorized data thinks is the best answer. That's it. In fact, hallucinations is actually a terrible name. Anyway, I don't want to spend too much time. I've only got 20 minutes. So when we talk about retrieval, augmentation, generation, RAG, the box that gets most of the oxygen is the vector database. And this is a way to sort of take your data, vectorize it the way maybe it's set up in GPT-4 or in Claude, and this is what minimizes hallucinations. You never completely get rid of hallucinations, but what you can do though is if you're maturing your data in a corpus of data that's vectorized, it's similar to the foundational model, let's say GPT-4, then what's happening is it's actually using your data first to answer the questions. And then if you're sort of constantly running observability tools and evaluations on that, you're making sure those answers are really pretty tight. And you're actually monitoring for when those answers are incorrect and you're quickly addressing them. Right? So, but there are other forms of regs. Like there's a lot of cool ways within LangChain where I can just call APIs, create functions, and sort of embed my information. So the vector database is not the only way. It's just the easiest way to get more mileage than any other way, in my opinion. And so this is a gentleman who I've learned quite a bit, Joseph Enox. He works for a company called EVT, who's local in this area. He wrote this thing early on about how, I don't know if you heard of Perplexity, right? When ChatGPT came out, like it didn't give sources, right? And then Perplexity came out and they gave sources. And they're like, this is great. I don't need Google anymore. This is awesome. But he wrote a blog where he replicated it in like a day and a half. Truth is, right now in our workshop, we could have replicated in 3 hours. Right, the tools are so easy, and they asked a question about open source. Like open source has been a phenomenal enabler for this world, right? The point here is that yes, it is incredibly easy to get reasonably high efficacy on certain data points. So if the answer is that I just want to put an LLM to answer questions about my favorite candy, or right, like the point is that's a very simple task. In fact, I don't even think you have to go into Python. You could probably just load stuff, a PDF into Claude, or use one of the plugins in OpenAI. But again, if the answers are high consequence, it could create reputational damage to your brand. It could hurt somebody. Then the answer is this is not. You don't take the simple approach. And so if somebody tells you, "Oh, that's simple. Why are you doing all that work?" Depends on the answer and what the consequence of the answer. So the idea behind this RAG process is there's a lot of fiddling, right? Like you get your data in some format. It's either PDF, it's in Markdown, it could be SQL, it could be JSON. It could be any kind of format. And like these orchestrator tools, Llama Index, and I'm going fast, sorry. Probably got about 15 minutes left. Llama Index or LangChain are probably the two most popular in my opinion right now. They all handle this process of loading data. Like they've made it incredibly easy. Like if you look at the LangChain list, there's JQL for Jira, there's SQL, there's just about any format you get in. Getting the data to render properly is a whole nother. But then you go through this process called embedding, which is really vectorizing your data. Right? What you're doing is like, again, what you want to think about is what foundational model am I going to use as the backing? Like if it's GPT-4, then I want to find out what is GPT-4's suggested embeddings. Then I'll take my data and I'll load that data against those embeddings. And I know there's a lot of jargon here. And then I'll put it in a vector database that looks identical to the GPT-4 vector. Right? And just quickly on a vector. So the idea here is, like, we kind of all know this, right? It's sort of an autocomplete on steroids, right? If I say, I think, therefore I, right? I'm going to, 99% I'm going to get I am, right? But the way these things actually work is there's sort of pipeline of next word predictors. And then that pipeline gets next sentence predictors. And those sentence predictors get the next paragraph predictors. And that's like incredibly complex math. But the simplicity of it is when you take your data and vectorize it, whether they're doing it when they're training their models or you're creating your own vector, you're literally just putting words, and they call them tokens, in highly dimensional space. So if you think about like a two-dimensional, right? We got X, Y, tells us where it is in chart. Three-dimensional is X, Y, Z. GPT-4 is 1536 dimension. So what that word cat is actually, and you'll see this when you write code. In fact, some of the people who are annoyed in our workshop with, you're going to have to scroll down. It'll show up as 1536 floating point numbers. And that's where it is in this 1500 dimension. And then here's the key. The next word predictor doesn't always have to be, but the default usually is what they call cosine similarity. And what that is the angle. So the closest angle is the next word predictor. And again, it gets way more complicated than that when you start thinking about how it's predicting how to write a whole paragraph for you. But it all fundamentally starts from there. And then it gets crazy with the math. And then, so another thing that you do is when you're taking your data and you're preparing it to get embedded and then vectorized, you do a thing called chunking. And this is where you can read a gazillion blogs about a gazillion ways of the best way to do it stuff. But in the simplest format, there's like these character chunkers where they say, hey, I'm going to take my PDF and I want every 256 characters and don't break up a sentence. Bang. And that might be fine, depending on what kind of answers in your prompts you want to get. A more sophisticated version is what they call the recursive character split. And these are all LangChain examples, but Llama Index has similar ones. And this one's kind of cool because you can get a lot of bang for your buck out of this, depending on what you want. Because what it will do is it'll make the chunks in whatever size you put. And then playing with the chunk size, you get to know, are the answers better or worse? Like, almost like, in fact, there's some GUIs that I may have time to show you in a demo where I can slide the bar and say, let me try 400. Okay, those answers stink. Let me try 300. Oh, that's a little better, right? And it's all about how the data gets clustered. But what the recursive character splitter does, it has logic in it that won't cut up a sentence, won't cut up a paragraph, it won't cut up a page. But it will try to honor the chunk size. And then the overlap is just in case, like where we need a little bit of overlap, we don't want to, so it gives us sort of a buffer on both ends. And then there's Markdown. I found Markdown tends to, it was kind of interesting. My book was never in Markdown to begin with, but then I put it in Markdown and I got way higher, what they call relevance, correctness, similarity scores, and even the answers were better. So sometimes, but I don't think that I'm telling you that's the best way, because it is about the data, stupid, right? It is, but I find a lot of cases if I can get it in Markdown, because what Markdown will do is split on the headers. So if I got header 1, header 2, I'll say I want to split on header 1, header 2. And my book wasn't in this format, but I took chapter, subsection. And by doing that, the chunks were placed in the logical sections automatically by just pulling that out. And then Mary talked about the stack. The stack would be sort of your orchestrator, LangChain or Llama Index. It would be a vector database. MongoDB, I'm a fractional evangelist. How do you like that? I'm a fractional evangelist. I am, actually. I made that term up. Fractional evangelist for MongoDB. And so I'm working very closely with their vector database. And I happen to think it is the best, but I'm a little biased, but I'm trying not to be too biased. So you have basically the stack that I'm thinking a lot about is the orchestrators, the vector database, and I'll show you examples of some other vendors other than Mongo. And then there's orchestrators. And this tool I love. It's by a company called Arise. It's fully open source. It's brilliant. And they have a pay for one, but their open source does almost everything the pay for does. And it's just amazing. So the idea is that as I'm putting my stuff in the vector database, these evaluation tools, or orchestration tools, will tell you your relevance, your correctness. It'll tell you if it's hallucinating. It'll actually give you all sorts of data about any drift, even as you're ongoing. So you could set up like a corpus of data, a corpus of questions, and then continually be running these evaluation tools that are always telling you, are you drifting, or is your relevance gone down? So, and they're looking for hallucinations. They're looking for toxicity, bias. So this is your way you monitor. In fact, observability in DevOps is different from observability in generative AI. There's overlap in between latency and stuff like that, but the real key is these things are using LLM-like logic to figure out, are you saying the things that you want it to say? And so what are you looking for in sort of like the full end-to-end? You want to make sure you're eliminating hallucinations to the point you can't eliminate them, but you want to make sure the relevance is in the high. If it's high consequence, you can actually score these from 0 to 100. Right, and you want to make sure it's like 95, 96%. I mean, again, if it's really critical, if somebody was a lawyer on the thing, like if I don't want an answer to like mix up some jurisdictional thing that was already in place. I mean, I can't guarantee these are non-deterministic engines, but if I can basically mature my data to a 96% relevance with 0 hallucinations based on everything I have at this point, I've done my job. And probably the lawyer can correct me, I've done my due diligence, so I've somehow protected myself from liability because I've at least tried to. That's how I've lived my life, right? As long as I have proof, as long as I have proof that I tried to. Relevance, bias, toxicity. Doesn't always work, though. And then there's some things that you need to understand. Again, this is the rocket ship version of all this, but I talked about chunks. You need to understand tokens. Words actually get put in as tokens, not words. So there's a lot, you can read. The dimensionality of the embedding, right? We talked about that, 2-dimension, 1536. Metadata is really important. And not only metadata in the embedding, but metadata outside the embedding. This is another reason why I like MongoDB. MongoDB puts the embeddings in the document objects. So you can have all your sort of metadata in the object as the JSON object, and then have the embedding as just another field. So now I can use the power of slicing through. Give me all the document objects that say, for example, give me all the incidents for Department 5 that happened in the last 3 months, and none of that's actually an LLM question. And then what give me back is all the embeddings in all those documents, and now I can start asking questions like, what was the worst problem? What was that? So that combination of using metadata externally and internally becomes incredibly powerful. And then indexes, every sort of, like any of the tools that you want, like a Pinecone or MongoDB or anyone, you have to create an index which declares the fields and the dimensionality. So, and then like this is a very busy slide, but this is my sort of ongoing list of like all the things you've got to do, to get high efficacy data. That's not a data science term, by the way. But you have to like metadata. Like believe in metadata and just be incredibly creative about it. Summaries and chunks. So as you're chunking the data before you vectorize it, like one of the things you can do is if I want to get great answers. So I've got this documentation. I've chunked it up in a certain way, either by markdown or header. But there's something a little bit more that 1 minute, holy crap. All right. Yeah, so the point is I can embed additional information in my chunks before it goes to the vector. In fact, one great example is if the most important answer for this chunk of data, put that answer in the middle of the chunk before you embed it. You can red team, get like, as you're sort of launching this thing, don't just give it to everybody day one. Just like we do canarying and that kind of dark launch, we would send it out to small groups of people. We'd add more people. They'd be giving us feedback. We'd be looking for hallucinations. And then, so just some of the things, I won't really have time, but some of the demos, this is an interesting thing. So some of the code here, this is all in the workshop. So if you ping me, I can get you sort of the workshop stuff we did. But like trying out different embeddings. And there's actually really good embeddings that are free and cheap that sometimes work phenomenally well. So you don't have to start, even though my labs start off with OpenAI and they right off the bank, because it's the easiest way to get started. But as you learn, you can find out, like there's the one I like is this Beijing Institute. And it's like very low cost. There's in fact no cost, but low cost latency and low cost memory, all that stuff. And in some cases, it gets just as good results as the OpenAI embeddings, right? So play with your embeddings. And you can just start playing, use this embedding, try it, use this embedding. And you can see down here, for a certain question, I'm actually getting similarity scores. So, and I can see sometimes between 1 and 2 embeddings, I can find 10-point difference in the similarity score, the cosine similarity score, right? I've got my book out in Hugging Face, so I've got some labs where you can take those and use that as a corpus of data. This is actually what MongoDB looks like. You can see all your so this is actually a client of mine where I'm building all their product documentation into Vector. So we're creating a chatbot for all their documentation. And the nice thing about Markdown is, I'm going to steal, I'm going over, sorry. If you set up your Markdown right, like especially for product codes, like if I identify like the 3 ticks in the Markdown, it magically gives me code segments. So like I can ask a question for the Java component of this that does that, can you give me the code, the YAML statement? Bang. I didn't do anything. It's magic. All I had to do was make sure I chunked and said one of the header 1, header 2, the 3 ticks is a code block, So anything that you can think about, and you can make your own. I mean, like you could literally create your own sort of like separate.
Thank you so much. That was awesome. The deep dive. Appreciate the abbreviation and the workshops making those available.